The work that we do is really thinking about the function within the soil, and we don't really chase adding microbes to the soil. What we look at is creating a soil environment which is hospitable to microbes so they can perform their functions.
G'day, I'm Craig Allen, and you're listening to the Healthy Soils podcast, a series about compost and how it can help create healthy soils that then grow the food we eat in Australia. The purpose of this podcast series is to help make the connection between organic waste generation and food production, and to inspire you to think about what you can do when it comes to organic waste, including food waste and compost. On this journey, we'll be talking with farmers, composters and soil experts about the role we can all play in getting organic waste out of landfill and instead turned into compost. Because healthy soils produce healthy crops, which lead to healthy humans and animals. In this episode, we're looking at the science of compost, how it benefits soil health, which covers everything from the microbes in soil to increasing soil carbon to increasing water holding capacity and more. That's why we're talking today to Dr Susan Orgil, who is an applied soil scientist with over 15 years' experience in soil carbon research and development. Susan is passionate about working with producers to find ways to increase the productivity of their soil and to help build sustainable farming systems. Soil carbon is her wheelhouse, and she spends her time developing innovative strategies to build soil carbon under pastures, cropping and other systems. I'll let Susan explain more about soil health and where compost fits in.
What I love about soil science is it is such a tactile thing, right? Like, I love talking about the feel and the smell, and there's scientific tests that we can use to test that, which tell us about soil condition, because health is around something that is living, which soils are, something that needs feeding, which soils do, and something which is active, which soils are as well. So around soil health and soil quality, there's been a lot of research around the fundamental kind of indicators on water holding capacity and nutrient availability and the importance of air in soil, and that's provided through soil structure, which provides good soil condition, high quality soil and a healthy soil. With soil chemistry, we know that in terms of soil's ability to store and supply nutrients, it's going to be determined by a few different things. So it'll be determined by the amount of clay and type of clay mineralogy and clay content. That's kind of hard to change in a farming system, but it's also determined by the amount of soil organic matter, right? So that's how we actually improve cation exchange capacity and that nutrient reservoir capacity of soils. When I think of compost, it's about kind of fast-tracking some of these processes. So compost is a really good source of biology into the soils, but most importantly, it's a source of stable carbon, so that's gone through that maturation process. It provides habitat for microorganisms being put back into the soil, and it's an important source of nutrients as well. It's highly complex and it's alive and it interacts with the soil when we apply it, and that's a good thing. We don't want to put a compost in the soil and it to be just static. We want it to spike life within the soil.
Susan boils it down to three main factors when it comes to compost bringing life to soil: organisms, microbes and energy, all working together to activate the soil.
And that's primarily driven through three things. Through the nutrient capacity, part of it, and that might be the resident soil organisms using those for energy, or it might be spiking the soil with those microbes, and also the ability of the soil to have these plant growth kind of signals come back into the soil. So it's similar to like a plant growth promoting hormones, so that this compost can stimulate roots to change their exudates, which is really important for the indigenous soil microbes as well, so the ones that were already there. But I think even more importantly, it's the energy that that compost brings back to the soil. And we know that Australian soils have experienced like a historic decline in soil organic carbon. A lot of them are quite old and tired, so compost is a way of fast-tracking some of those processes. We know about the processes that happen within soil, right? So we know that when we've got processes which build organic matter in soil, we know that there's the quality of yield benefits with the application of compost. So when plants are growing and experiencing different environments or different signals, they might be chemical or it might be related to soil temperature or soil moisture, they can change the composition of their root exudates within a matter of kind of minutes. And we're only just starting to learn about the complexity of that root exudation process. It's a really exciting carbon economy within the soil. It's the most exciting part about soil carbon science, I think. So you can start the process with compost application, and there's a whole lot of questions and considerations about the type of compost and the rate and the timing and the application method, but it's part of a program for a farmer, right? So it's not just compost on its own, it's not the silver bullet, but it's a tool that farmers can use to kickstart that soil health process. Then it's thinking about those other complementary activities around grazing management, green manure crops, crop rotation. So it needs to be part of a program which continues to build soil health. And essentially what we're trying to do is build farming system resilience, right? So we're not thinking about soils or cropping or grazing in this static kind of form. It's thinking about this transformation of our farming systems to improve soil health over time. And compost is one of those tools which will be suitable for some growers.
That's what this podcast series is all about. How compost can be a vital tool in helping to transform farming systems. Not only that, but it is a tool that can be used to develop soil resilience, and Susan explains how that can help farmers protect against weather extremes.
When I think about resilience, I'm thinking about the system's ability to respond to these disturbances that are happening within our environment now. So if we think about the one that always comes to the top of the list, is around kind of drought, for example, or drought-like experiences, so where we're kind of getting these dry seasons. Resilience to me is the soil's ability to hold on for longer and to respond quicker. Because if you're in a situation where we know that we can maintain ground cover and maintain active soils and healthy soils for longer, and then they respond quicker once the season does change or conditions get more favourable, then we know that we're on a pathway to a more resilient farming system. Resilience can also be around the other effects of things like pests and diseases coming across. So compost is another very good example around where you can enhance a plant and the soil's ability to suppress diseases and pathogens, right? And the plants which are most susceptible to diseases and pathogens are ones which are under stress, right? So they're not resilient. So having both physical, chemical and biological resilience within our farming systems means that they can respond quicker when those disturbances come in, be it a climate disturbance or be it maybe a pest or pathogen. I'm a strong believer of making sure that we've got as many tools in the toolbox as we can. Like I try not to rule things out in terms of inputs or chemicals or, for example, strategic use of tillage. Like there'll become a time where you may need to call on a whole different tools in a farming system. Farmers who are striving to achieve resilience in their farming system and their farming business, they want to maintain a profit, so they're kind of reducing the cost of inputs at the same time as improving or maintaining productivity. And that's also a really good indicator of resilience as well. A lot of our cropping soils and grazing soils have experienced a significant amount of soil organic carbon decline through practices which have been implemented over decades. That said, with the conversion to conservation agriculture 30 or 40 years ago, we've seen a rapid turnaround in terms of soil conditions, so an improvement in that with some of these conservation ag practices. So once we start to reach that equilibrium again, we think about what's the next stepwise change that some of these farmers can start to adopt. And compost will be one of those tools if it makes economic and farming system sense to use that. If people look at compost just for the nutrient value, and I get a little bit frustrated where people will say a ton of compost and you only get this much nitrogen and phosphorus, so this is how much you're actually paying for those nutrients. I think it kind of misses the point of what compost actually is about.
The economics of compost is an important consideration for farmers. So how does compost stack up when it comes to cost versus return? Susan explains how applying compost is an eligible management practice under the Emissions Reduction Fund that can earn you Australian carbon credit units.
One of those eligible management activities is around the supply of nutrients, and that can be in the form of compost. According to the method, it's referred to as non-synthetic fertilisers. If by the application of compost, you improve the soil conditions so that plants grow bigger and healthier and they are sequestering more carbon, then the carbon increase could be claimed for credits if it's a registered project, and then there can be an income generation from those carbon credits. Compost is the nutrient source, but it's also stimulating other benefits in terms of plant growth, and it's those differences in soil carbon and increase in soil carbon over time, which could be eligible to claim credits for if it's a registered project.
And Susan's not just talking about topsoil. She explains how applying compost to the subsoil can be transformative.
Thinking about compost is typically we think about it being broadcast or gently incorporated into the topsoil, but thinking about some of these organic products and organic amendments such as compost being applied to the subsoil, and that's a super exciting area. If we think about our subsoils in Australian farming systems, particularly grain growing regions, the water limited yield potential is because of a subsoil constraint. The exciting thing with the organic amendment is that what they've seen, and you look at the literature, is that typically when you have an amendment such as lime or gypsum in the subsoil, you get an impact down, right? So it goes down through the soil profile. If you have an organic amendment mixed with that, so such as compost mixed with lime or gypsum, so the lime or the gypsum, that just moves down, so it just moves with gravity and water through the soil profile. Whereas having an organic amendment there, you bring life to the soil, which actually brings this, it changes, I guess, the community within that part of the soil profile. That's super exciting. And I reckon when we're thinking about carbon accumulation across the profile, we know that our subsoils, they're less saturated with carbon, but also we know that through our chemistry testing. They've got a higher concentration of clay, and we know that clays are really important in stabilising soil organic carbon. So subsoil amelioration, where compost or an organic amendment is part of that, is going to be a game changer moving forward. And that's what leads to bigger and healthier crops. And coming back to that point of resilience, a more resilient farming system, because plants are able to access moisture across a greater proportion of the soil profile.
One way to help apply compost is in pelletized form, where it can be sown directly into the soil next to the seed. Susan explains what it is and how it works.
So pre-rolled or pelletized compost is a good technology where we're in a system which is minimum till, and we want to get that incorporation of compost direct into the soil. It can be a little bit more expensive than broadcast or bulk compost, but in terms of making sure that you get those microcosms of biologically active compost directly into the soil, it can be a good application method where you can then directly sow it into the soil and you'll have these microcosms of kind of organic and microbially rich zones within the soil. That is going to be a game changer. Any technology where we can put it down a tube and get compost directly into the soil can accelerate some of those benefits and have those kind of microcosm effects of nutrients and carbon energy going back into the soil. And I think key to that also is thinking about compost application in drill lines so that it's close to the seed, so you get that immediate plant growth benefit from having compost there. And in that sense, it doesn't have to be compost everywhere all the time.
What about graziers and croppers? How can they fit compost into their farm systems?
If we think about grazing systems, like the obvious one would be if there's a new pasture that's being established, so having it as part of the pre-sowing preparation and incorporating compost into the soil. If you don't want to use cultivation, it's about using livestock and grazing animals. So one of our projects at the moment, they'll bring livestock through early, and then once they've grazed the pasture down to still having good ground cover, but where compost can be surfaced, applied and broadcast, so it gets that surface soil contact, that's when they'll look at the application of compost. And then there's a slight withholding period with grazing animals coming back to make sure that compost can be incorporated back into the soil. Similarly with cropping systems, in terms of the preparation period before a crop is when you'd actually want to be applying compost. Slight incorporation of compost brings better yield benefits and more immediate yield benefits, looking at complete no-till practices, which is important then to think about, well, how do you get good surface soil contact? Make sure that you don't have compost that's just desiccating on the soil surface. So thinking about sowing preparation and time would be some of the things that we would consider.
We've talked about soil health, subsoil, and how compost can help transform farms, with healthy soils being more resilient. Susan talks more about soil microbes and the impact of having a diversity of bacteria and fungi.
The work that we do is really thinking about the function within the soil, and we don't really chase adding microbes to the soil. What we look at is creating a soil environment which is hospitable to microbes so they can perform their functions. We've got these chemical drivers, physical capacity and biological enablers within the soil. We know that there's going to be different ratios of bacteria to fungi, but if we're thinking about the role of those microbes, they're providing those really important functions for nutrient availability. So diversity, like anything in the soil, it's a living, like anything on our planet, like having diversity gives, again, that resilience so that you've got a microbe or a community for all different experiences that you might have in terms of wetting, drying, disease and pathogens. A compost which kind of spikes the soil back with new and additional microbes will also have benefits and their associations with the plants that you'll be growing. When we think about organic carbon or soil organic matter, which is what compost is, being a reservoir for nutrients, we know that by increasing soil organic carbon through the use of products like compost or through plant growth and the decomposition of organic matter within the soil, we can increase the amount and storage of things like nitrogen, phosphorus and sulphur. So a 1% increase in soil organic carbon, so say from going from 0.5% soil organic carbon to 1.5%, gives us an extra tonne of nitrogen per hectare. Now, the way that compost enhances water holding capacity is by feeding soil microbes, right? And the so compost itself can hold up to 5 times moisture, so that's important. It's a sponge in itself. But really the role of compost is breaking down in the soil, right? And bringing, life to the soil or enhancing life within the soil. As bacteria break down soil organic matter, they'll exude polysaccharides, which sticks particles together, and then particles become crumbs of soil, and it's crumbs of soil or soil aggregates which can hold on to soil moisture. And thinking about being a bit more outcomes focused, so going, like, why do we want to use compost? And so, it's around kickstarting the system. So it's not going to be doing it all the time, but it's doing it that well once. And then thinking about in the right place at the right time, and then kind of making our recommendations towards that. But it is kind of one tool among many, so it shouldn't be viewed in isolation.
Thanks to our guest, Dr Susan Orgil, an applied soil scientist who has beautifully unpacked the nitty-gritty of soil health and compost for us today. You can hear from farmers and compost manufacturers talking about their experiences with soil health and compost in our other episodes, which you can find wherever you find good podcasts. Thanks for listening to the Healthy Soils Podcast, a series about the wonders of compost. Be sure to subscribe or follow our show so you don't miss out on future episodes when we get down and dirty into compost and how it's changing our soils for the better. You can find more information about what we discussed in the show notes, or you can go to the website to find out more. I've been Craig Allen. See you next time.